All right. Well, thanks everybody. Thanks for being here at my talk. We're going to talk about what I call the new foundations of SBOM, which is sort of mentioning the work that's been going on in the OpenSSF projects and where they fit in a bigger kind of landscape of SBOM. So if Mike talked about the sandwich, this is talking about maybe just the bologna and how it's composed. All right, so about me, my name is Adolfo García, or Puerco. If you've seen that pig around in the internet, it's me. I am one of the technical leads with Kubernetes SIG release. I work together with the release engineering team on the tooling that releases Kubernetes every month, and that includes all of the supply chain improvements that we try to maintain there, that build SBOMs, sign releases, generate provenance attestations, and all of that fun stuff that we love in this group. On the OpenSSF, I also lead part of the leads of the OpenVEX project and protobom, which we're going to be talking about today. And I generally like to build SBOM tools that solve several problems. My day job is with Stacklok. We're a supply chain security company that helps developers build more secure software and also make better decisions when they choose which dependencies to rely on. The first thing is, I would like to start by talking about photography. And if you think about photography and all of the benefits that it has brought to humankind, photography has allowed us to capture our history, to register all of the beauty surrounding us. It has allows us to capture all of the diversity in the world and register our culture. By leveraging the images that photographs provide us from the past, we can understand what happened in the past and then how those events configure the moment that we're living. So when you think about those complex relationships, they all played a part in leading us to where we are. I think a really great example, I just heard in the news, I don't know if you saw it. Did you actually know that some of the founding fathers in the US were black? This is amazing stuff that just came up. So keep that one in mind because it's going to play a part later on. So the analogy I'm trying to make is that SBOMs are sort of a picture of your software. When we generate SBOMs, we're actually capturing into a format all of the diversity that the software ecosystems have and how they compose software. When we generate SBOMs, the tools that we use capture the software structure and how those components are assembled together to actually produce the piece of software you're looking at. We also capture some metadata, like, for example, the name of the components, its license, some of the versions, the time it was built, who supplied it to you, and things like that. But in the real world, there is no one single camera looking at software. In the real world, what we're doing is that we're pointing many different cameras and generating all sorts of SBOMs and most of the time, all of these tools will be looking at things that are important to them. So some tools will try to only extract information that they need to act on. Some try to be very general. Some try to be very specific on where you run them. And in fact, if you think about this, having more data about the software that we're running should be, quote unquote, a good thing, because having more data lets us have a more complete picture of the software that we're running. But this is not, having multiple SBOMs has been proven to be kind of problematic because of some basic problems that we have. And let me give you an example. The SBOM community has identified I think it's 6 different moments in the software development lifecycle where generating an SBOM can provide you value. So for example, if you are running an SBOM generator that understands source code, it can look at that code base and give you information about what it's lying in your repository. So the dependencies that it's pulling or the possible dependencies that it may run. If you're looking at if you're generating an SBOM from something that looks at your build process, then that tool may be able to capture the decisions that your compiler or your interpreter is doing when deciding what dependency to pull in. So if you think about this, it would make sense to take all of our cameras and point them because they're supposed to be very specialized and they understand each of those phases. And then we should be able to assemble a great picture. If you were at Kate Stewart's talk this morning, she actually kind of painted the picture of where all of these SBOMs come together. But in reality, we're not seeing this. Oftentimes what you'll see in projects, and this is mostly true for open source projects who have, well, they need resources, you'll see something like this. People will take a camera and it will, like a tool that generates SBOM, and it will often be not a really good camera and pointed at one of the software development lifecycle phases. And then they will generate an SBOM. But the problem with that SBOM is that it'll often be something that it's designed to play well when it's a commercial vendor with that vendor's tooling, or in, I don't know, in a less worse case, in related to play well with other ecosystems of the same tool. And even worse, when people find an SBOM tool that they like and they get used to it, they will use the same tool anywhere in the software development lifecycle. And this is really problematic because the SBOMs, if you apply one tool that understands one of those particular phases to other phases, you will only get crap SBOMs that don't really work for anything, not even with the ecosystem they're supposed to play with. So when you have one of those SBOMs, the tools, and some of them will really try to do a really good job of understanding what happened in the past, but it's not. So it's kind of the analogy of the AI images, because they're trying to understand the past by looking at the data that's available today. So the reality of this is that some of these problems, we shouldn't have them, because some of those problems should be, I don't know, at least should be solvable, but I feel that so far we've been trying to solve them. Everybody tries to solve them over and over at once. So things like, for example, focusing on the subject, you'll generate an SBOM, and one tool will give it identifiers which don't match the SBOM from another tool. So if you take all of these pictures from the Mona Lisa, they're different pictures. They all look different. They're trying to capture different things, but all of them, you can find the Mona Lisa in all of them. And we should be able to do that with SBOMs no matter how they're structured. Then relying on the SBOM formats is another one. Too many times I've seen tools relying and building their internal data structure based on the format. So if you're working with StackLok, all of the internal tooling is StackLok. If you're working on SPDX, the internal model is SPDX, and this is wrong because then you're open to obsolescence when formats change, interoperability problems, and all of that. So I should be able to take, if I try to have a good picture of Lina here, it's a common image used in photography, I should be able to just use any format, and each of those formats will capture different things and be focused on different use cases. Another problem, for example, not trying to improve the picture quality. So here we see the first picture ever taken. On the other side, it's the highest resolution picture ever taken. And oftentimes, if you think about it with a cold mind and from an outside perspective, what you want to do is get from that to that. And you'll oftentimes what you'll find in the SBOM community is more critiques. For example, I love the pictures of Jupiter brought by the Voyager probe, but and I have that picture and I don't really care the format that's underlying when the probe sent the picture back to Earth. But in the SBOM community, well, you'll often say like, oh, nice picture, but that format doesn't support any formulation, so no. So what do? We build new SBOM foundations. And I chose to call them SBOM foundations because it's been a really great experience seeing how people interested in these projects actually come together and put, expertise to work, to actually produce software that solves these problems. So the first one I want to talk about is protobom, and I mention it not only because I'm involved with it, but also because it's kind of the underlying thing that the basic foundation on where we built on top of. So what is protobom? Protobom is a project that was founded by a grant contract from DHS through their Science and Technology Directorate. And they had the good idea of funding 7 different companies, which it could be in theory and in real life competitors, because they're working on the same space, and kind of forced them to work on a problem to solve some of those SBOM projects. Protobom came out of that, and when it reached a certain maturity level, we started the donation process to OpenSSF. The project was always open source in the beginning. And what is protobom? So protobom is an abstraction of the SBOM graph data. Protobom will look at your SBOM and abstract it, and you may be asking, why is it a graph? And well, the answer is that both SBOM formats are in reality a graph. SPDX was born since the beginning as a graph of linked data. So you have packages and files, and all of them are linked through relationships which are typed. CycloneDX started as a tree, which is some sort of a simple graph, but it also has now the dependency graph, which makes those relationships more complex and also becomes a graph. So what we do in protobom is we take those basic building blocks, which are the packages in SPDX and the components in CycloneDX, and we start modeling them into internal representations of nodes inside of protobom. So we put them all together, then we turn them into we type them to represent either packages or files in protobom, and then we add types of those relationships, and then that gives us the protobom graph. We capture that in a structure that's defined in protobuf, and then any application can make use of it. The second thing that protobom is a library. So we've been building a library currently in Go that basically can read any SBOM format. So we have specialized serializers and unserializers that when you read and ingest the SBOMs, make those decisions on where things go where in the resulting graph, reads them to the protobom representation. Any application can use the resulting graph. And if you need to output any native format, you can go from that representation to the native formats. We currently support, I think it's the last 3 versions of CycloneDX, SPDX 2.2, 2.3, and we have a beta of SPDX, which is coming this week. The next thing that protobom offers is an API to perform queries on that database. So the protobom library has APIs that let you, do things like union querying, basic querying on the graph and making difference of nodes, and so that you can make it. And then the other important thing to note about protobom is that protobom is only about the bill of materials part. If you have been in the SBOM talks this morning, formats are expanding to cover lots of other use cases, like you can do whole advisory, security advisories in SBOMs. You can do bill provenance in those formats. We don't care about it. What we care about is just having a workable bill of materials format, bill of materials structure that we can use in our applications, and that can be exported to the formats. And what it's not, and this is, I want to be very, very emphatically, protobom is not a third SBOM format. We want to avoid any perception, any kind of suggestion that we're building one. The protobom structures are not designed to be easily interchangeable, so none of that. So, the next level of the foundations. On top of protobom, we are starting to build some interesting projects. So, as I mentioned, the very, very basic foundation of all of this stack are the native formats. So people should generate their SBOMs and consume their SBOMs using the native formats. They have the greatest design put into to make them really expressive, to capture what's important. They also offer additional features beyond just the bill of materials. And on top of that, we have protobom. Protobom, and by the way, shout out to the OpenSSF that like designed a mascot for the project. Thank you. So using protobom, you can go back and forth from those native formats. Then on top of protobom, we're starting to see some very interesting projects that try to address specific problems. The first one is bomctl. Bomctl is trying to become, I would describe it as the Swiss Army knife of SBOM. So using bomctl, you will be able to do from your CLI, from your command line, things like querying those SBOMs, merging them, all of those things that that people who are working with several SBOMs need to do, like combine them, all sorts of that goodness. Something that I'm really happy that is happening from the collaboration with bomctl is that and this just happened over the past 2 weeks, we now have plans to offer a storage backend system for protobom. So the idea is, right now we support reading and writing to files, but from the work derived from bomctl, we will be able to store the information in the SBOMs into databases with a pluggable backend. So shout out to Jonathan Howard from Lockheed. He has been really putting up with the project, and we came up with a really nice solution, which should be coming up really soon. The next one is, of course, SBOMit. SBOMit, what it tries to do is answer the question, can I give you, with an SBOM, proof on how I generated the SBOM? So in other words, if I get an SBOM, can I embed some information in it that gives me assurances that it has not been forged? So some of the POCs have been using protobom for that. This is like a little bit of an advertising. I have a tool called bombctl, and what bombctl does is that it exposes a CEL front-end, CL common expression language, which is sort of a querying language that lets you do querying inside of those SBOMs. So you can potentially use that to create things like policy, things like extracting bits of the information. Part of the protobom project also funded SBOM convert, which is a CLI that does basic conversion, well, basic, not that basic, conversion of SBOMs from one format to another. And on top of that, so these tools are very specialized on the simple projects that they solve. They solve things like merging, things like trust, things like querying for information and conversion. So once we have assurances that we can do all of that magic with SBOMs, we can scaffold one level up. And then you start seeing things like, for example, in OpenVEX. OpenVEX, which is the VEX flavor that's cooking inside of the OpenSSF. OpenVEX can read and act and look for VEX information from your SBOM, regardless of the format you're using, because it scaffolds on all of these things below it. GUAC will be able to benefit from it because GUAC is not in the business of understanding formats. It's not in the business of trying to make SBOMs even. All of the tools below it should be able to do that for the project. And finally, your application. So one of the things that we would like is for people to start using protobom as their I/O layer for SBOM. So if you have an application that reads, if you have an application that writes SBOMs, it doesn't mean a generator. It just, you output CycloneDX or SPDX data. We think we have a good case for you. We are looking for help, but I'm going to talk a little bit later after that. And finally, the great part about all of this is, if you heard Kate's talk this morning, the formats are expanding to other use cases like AI, security, and build. And if you're using protobom, nothing stops you because we still keep the data that's shipped with the SBOM. Nothing stops you from referencing from the protobom those other documents to find the additional information. So you can work the SBOMs with protobom and still reference all of the security information, all of the build provenance information that may be contained on those SBOMs. And yeah, so please, if you're working on something SBOM, we in protobom, and I say we in the overarching community of the OpenSSF, I think we would like to hear what you're trying to do. Are there any problems that you're having? So if you are hitting some problem that you think others may be experiencing as well, talk to us, share your solutions, hear what others have been doing as well. If you're generating or consuming SBOMs, please join us. And in fact, if you're SBOMing anything at all, please come join us. The conversations are endless, always fun, but they tend to need external fresh blood from others to make them more interesting. So yeah, this is what I have. And thank you. So these are the links to join the project. So if you want to please join our meetings. And we're also on the, we have a dedicated Slack channel on the OpenSSF Slack. And yeah, come talk to us. Thank you.